Там написано, что выключить звук. Я вот туда нажал. Динамик. У меня 100% стоит. Да. Ну, не знаю. У меня сын настраивает. Поэтому я не знаю. Угу. Раз. Слышно ли меня?
Так намного лучше слышно, да.
Ну, замечательно.
Угу.
Hello, dear colleagues.
Good afternoon.
Hello.
Good afternoon. Namaste ji.
Namaste.
Good afternoon.
Hello.
Hello. Good afternoon.
Oh.
Yeah. So, good afternoon, everybody.
Good afternoon.
So, shall we start? Time?
Yes.
Audible? Yeah.
Hello.
Hello.
Yeah.
Thank you very much for asking me also to participate at least vocally, if not physically. I'm not in a position to move around, but I continue to write on geography and history. These are two subjects which are very important to me. Now, geography, there is nobody can escape geography or history, because geography gives the natural environment in which we are born and in which parents are born. So that we can't escape. And then history is what our parents and grandparents have created. And therefore, these are two subjects which are very important. I'm glad that our Rai Saab and other friends in the geography department have invited the Russian geographers for a meeting together. And the Department of Geography in Delhi University has been known for good work for a long time, and so is the case with the Russian geographers. Friends, I welcome you all, and I hope that your stay will benefit our young geographers of India who will be assembling them. Anything else?
Thank you, sir.
Okay. Thank you, sir. Thank you, sir, for your blessings. And so welcome to the online roundtable conference on water resources. It is a nice opportunity to link with our Russian colleagues. And we have 5 panelists from Indian part. So we'll be discussing various issues of water resources, and particularly we'll be looking on through the geographical perspective. Now I forward to Elena, who can introduce about the conference, the theme.
Yes, thank you. And first of all, let me greet you on behalf of the Russian Geographical Society. As you know, we have the agreement cooperation with the National Association of Geographers of India, signed in 2015 in Moscow, and Mr. Rai signed it from the Indian side. And I'm very happy that we have now, in spite of COVID, such opportunity to continue our cooperation. And we will put our eye today on a very important item. It's a water resources and its state and ecological state and its influence of the environment. I wish to all of us the fruitful work. And I pass the word to Mr. Mikhail Naumenko. He is the head of the Hydrological Commission of the Russian Geographical Society and the head of Geography and Hydrology Laboratory of Institute of Limnology of the Russian Academy of Science. Please, Mikhail.
Oh, I can start.
Yes, yes.
Dear colleague, first of all, I should thank the Russian Geographical Society and National Association of Geographers of India for invitation of take part of online roundtable conference. I believe it is a good initiative for establish more closer relations between our country and our scientists. I will speak about Lake Ladoga, which myself and my team have studied during a few dozen years. But my talk will be briefly because I remember that I have only 50 minutes. Of the largest European lakes, Lake Ladoga, is almost submersional. Oh, yes. My main outline of the presentation are you can see in this slide. I will speak about geographical description of the Lake Ladoga and its watershed and major ecological problems. Some few words about detection of climate changes in air temperature, ice condition, and water transparency. Lake Ladoga is situated between 60 and 62 degrees of north in northwest of Russia. It ranks as the 18th large lake in the world by the area and the 14th largest by volume. There are two great lakes of Europe, Lake Ladoga, with area about 15,000 square kilometers, and Lake Onega, about 10,000 square kilometers. The bottom of Lake Ladoga features a pattern typical of an intracontinental glacial shelf with previous tectonic uplift. From the geological point of view, the main feature of the lake bottom is its location on the boundary of two geological structures, the Russian plate and the Baltic crystalline shelf, with determined differences of the depth distribution in the lake. You can see in the south part of the lake have depth about 20 or 30 meters, and in the southern part of the lake, the maximum depth, bottom depth is 230 meters. Lake Ladoga lies 5 meters above sea level, and also annual water level fluctuation about 1 meter. You can see how change during about 50-100 years littoral zone of Lake Ladoga. It depends on water level. May resident time is approximately 11 years. And it is main outlet is the Neva River, flows out from the lake with a mean annual exchange of about 2,500 meter per second.
Михаил Арсеньевич,
Yeah.
вашу презентацию не видно.
Видно? Вообще не видно?
Да, только вас видно.
Ох, как плохо-то.
Там есть значок демонстрации экрана внизу. А внизу в центре, видите, демонстрация экрана.
Не вижу. Excuse me. Уменьшение масштаба просмотра всех слайдов. Вообще.
Там зелененькая такая кнопочка внизу.
Не вижу.
Вы можете ее нажать и там выбрать уже вашу презентацию внутри.
Сначала вам нужно развернуть видеоокно на полный экран, потому что оно сейчас у вас, наверное, маленьким сделалось.
Сейчас маленький сделан, да.
Вот разверните его стрелочкой на полный экран, и у вас появится зеленая кнопка демонстрации.
Внизу такая зелененькая кнопочка демонстрация экрана. Вы набираете, нажимаете на нее и там выбираете вашу презентацию в окошечке.
Сейчас я стараюсь, но я не вижу этой кнопочки-то.
Вот
Сначала
внизу
нажмите на видео, на маленькое окошко видео.
Вы видите кнопки чат, участники?
Нет, я это не вижу, эти кнопки.
Вы видите окошко с видео?
Сейчас, секундочку.
Dear colleagues, sorry for the delay, but my colleague is going to switch on the presentation.
Excuse me. У меня с одной стороны изображение слайдов, с другой стороны следующая анимация. Вот что у меня сейчас на экране.
Выйдите, пожалуйста, из демонстрации слайдов. Escape.
Да, я вышел.
Вот, теперь нужно нажать на кнопку, на картинку с видеотрансляцией.
Вы должны видеть нас всех вот на экране, всех участников. Развернуть экран.
Да,
Вы
демонстрация.
видите нас, да?
Да, я сейчас вижу.
Вот,
И вот внизу демонстрация экрана.
Нажал.
И вот выберите, пожалуйста, там вашу презентацию. Вот. О, сейчас загрузится.
Да.
Отлично.
Теперь снова начать презентацию.
F5. Видно или не видно?
Да, сейчас видно.
Сейчас вы видите первый слайд, да?
Не, вот мы кораблики видим.
Ну да, то есть это кораблики, да. Запустить. Вот пошло. Что вы видите?
Надпись появилась. Вот сейчас вот поменялась.
Да,
то есть я сейчас листаю. Ну вот, давайте тогда я продолжу. Сейчас видно слайды?
Видно.
Да.
Ну, слава богу. Sorry for my demonstration. I speak about change of level of Lake Ladoga. You can see in this slide how change level during 50 years annual level change about 1 meter. And you understand that littoral zone can change its area depend on the water level. It is a situation when the water level was low and some bottom was clear. Lake Ladoga, located in boreal temperate zone and in Dimitic Lake, and experience a mean annual air temperature is about 3 degrees of Celsius. Lake Ladoga covers the ice during 5 months. Lake Ladoga is a large, open and deep lake with a surface area about 18,000 square kilometers, volume about 848 cubic kilometers, mean depth 48 meters. Watershed of Lake Ladoga is about 258 square kilometers. The largest rivers drainage into Lake Ladoga are Lake Volkhov, Lake Syasvir, and Burna. Outlet is River Niva, which discharge into the Gulf of Finland. Mean height of Lake Ladoga catchment basin is 130 meter, and principal direction that water flows over the surface towards the west. The largest lake in Europe, Lake Ladoga, was characterized by good water quality during some decade ago. Now, as a result of human impact, the saprobity and toxicity of water have changed. Phytoplankton biomass has increases and population of many sensitive species have declined. The state of its ecosystem results from a complex interaction of natural processes and anthropogenic impact of the lake and its watershed. Under water natural condition, the lake ecosystem was characterized by high water quality, but in the middle of 1960s, condition changed for the further. Morphological deformities of invertebrates are observed in heavily polluted area, and toxic effects are commonly encouraged in fishes. Any changes within the vast area inevitably influence Lake Ladoga. The lake is polluted by 594 industrial enterprises, of which about 200 are in the Russia and another in Finland, and 680 large-scale agricultural farms of the Russian part of the drainage area. Wood processing industry in the Finland are also affect water quality of the Vuoksi River and Lake Ladoga. Agricultural impact of water bodies are characterized by diffuse inputs of contaminants which make control and presentation of pollutant difficult. Nutrient in industrial, agricultural, and domestic waters cause eutrophication and lead to change in aquatic ecosystem. It means in increasing growth of phytoplankton and other plants and degradation of water quality. Spatial heterogeneity of limnological processes in large lake is connected with the morphology of the lake basin and the peculiarities of large-scale climatic and hydrological processes, leading to uneven water heating and cooling. You can see how change during the usual year temperature, water temperature, air temperature, and mean water lake temperature. Now you can see a cartoon movie about how change surface water temperature from spring to November. It is special distribution of water temperature in the surface of Lake Ladoga in middle of May. And it is changing from how water temperature heating in the 1st of July, you can see present. It is 50th of July at present time in the deepest part of the lake, temperature about 6 degrees in the surface of Lake Ladoga, but in the south part temperature about 20 degrees of centigrade. You can see how change. It is summer, maximum temperature about 18 degrees of centigrade in the surface of Lake Ladoga. And it is autumnal variation of temperature in the surface of lake. And The next slide show how change temperature in the vertical distribution from surface to bottom. You can see that Lake Ladoga is a very cold lake because only up surface 20 meters temperature reach about 20 degrees, and in the bottom temperature in every year changes from 2 to 6 degrees in every year. We somewhat about climate trends in air and surface water temperature in Lake Ladoga. We determined that there is a significant positive trend in air temperature in February, March, and April. You can see the value of this trend. And for surface water temperature is problem complicated because no significant trend in temperature for about 80% of open water period. There are short temporal scale comparable with synoptic period where there is significant positive trend. Lake Ladoga covers the ice about 5 months, and you can see how ice cover from space. From beginning of this century, ice cover degrees. And a few words about climatic trend of water transparency. Mean water transparency of Lake Ladoga about 3 meters, and we determine trends in different regions of Lake Ladoga, and it is about 1 centimeter per year decreasing. Okay, thank you very much.
Thank you, Professor. Our next speaker is Professor H.S. Sharma, who is a senior geographer, and he is the editor of our official journal of National Association of Geographers India, NAGI, that is Annals. So Professor H.S. Sharma will be speaking on climate change and its impact on water resources in Rajasthan, the western state of India. Professor H.S. Sharma.
Good afternoon, everybody. Ladies and gentlemen, at the very outset, I would like to congratulate both the association for organizing such a significant academic event between Russian Geographical Society and National Association of Geographers India. This is a unique opportunity to the scientists of both the countries. As Professor Saha has pointed out, that my topic of discussion is climate change and its impact on water resources of the state of Rajasthan. Rajasthan is a desert state, and climatic variability is very much in this area. Just a uncertainty of rainfall and increasing number of weather-related hazards and disasters. The analysis of excessive rainfall, droughts, changing nature of number of rainy days, and trend of temperature and rainfall during last 112 years or so make it clear that Rajasthan has been witnessing climate change during past and present centuries. We have tried to analyze the temperature data and what is the situation of mean temperature in Rajasthan. And we have tried to analyze decadal variation in temperature, particularly mean temperature. And this graph shows that after 1971 onward, there is a continuous trend of rise of temperature. If you see the 112 years of analysis at a decadal basis. This is also mean trend of mean temperature in Rajasthan from 2001 to 2015. And in this graph also it is indicated that after 1979 on 80 onward, there is a continuous rise and fluctuation in the temperature. When we try to relate correlation with the time and temperature, the correlation analysis of annual mean temperature with time series shows that 15 districts out of 33 districts of Rajasthan, these 15 districts are having a continuous trend and have a very significant warming trend, while 2 districts, Bhilwara and Bundi, have witnessed significant warming trend at a centennial time scale. The district of Sikar and Dosa have shown a cooling trend, although this trend is not significant, and this has to be verified why this cooling trend in these 2 districts in the state of Rajasthan is there. Overall, the conclusion is that the temperature have been showing a rising trend after 1981. When we analyze the rainfall data of Rajasthan, it has been noted that rainfall analysis of data from 1877 to 2012 reveals that the overall monsoonal rainfall in Rajasthan shows both an increasing and decreasing trend. There is no trend in the pattern of rainfall. We can say that it is a trendless. The decade of 1962 to 70 was a decade of declining trend of rainfall, while the period from 70 to 78 showed an increasing trend of rainfall. Again, declining trend has been noticed in 79 to 96 with severe drought of 1987, where minus 55% deficient rainfall was recorded in the state of Rajasthan. After 1987 onward, a slight increase in rainfall has been noticed. From 2000 onward till 2009, again a declining trend in rainfall has been reported, and from 2009 onward, there is an increasing trend of rainfall. At a centennial scale, when rainfall data was plotted, in Rajasthan showed that Banswara, Dungarpur, Jhalawad, Siroi, and Udaipur, yani southern districts of the state of Rajasthan, which were receiving more amount of rainfall in earlier periods, now there is a declining trend in these districts. And although there is no correlation value have been found, and there is no significant correlation. Annual total rainfall shows a decreasing trend in eastern Rajasthan because Aravalli range divides the state into 2 parts. On the eastern side of the Aravalli, there is a decreasing trend of rainfall, while annual total rainfall in western Rajasthan shows either no trend or a slight increasing trend, especially after 2000 onward. There is an increasing trend of rainfall in the desert part of the state. There is a Mount Abu station where decreasing trend in minimum temperature has been reported. The study further indicates that number of rainy days have drastically declined in the area and extreme rainfall events are more in frequency. The study further brings out the fact that there has been a shift of 15 days in the timings of the season in the state, and it has been noted from last few years. The analysis of cause of climate change indicates that both natural and anthropogenic changes are playing an important role. Now, looking into the changing pattern of climate and particularly the changing pattern of rainfall in the state of Rajasthan, there is an impact on water resources of the state, as Rajasthan state is one of the most water deprived state of India with respect to rainfall and per capita availability of rainwater. Being the largest state in India, covering nearly 10.4% of India's geographical area, but it shares only 1.16% of the water resources. The study further shows that the state faces acute shortage, scarcity challenges as rainfall patterns are impacted by climate change, increasing agriculture and industrial demand, is placing additional pressure on dwindling water resources. Rajasthan is among the regions of greatest climatic sensitivity and lowest adaptive capacity. This table shows that internal surface water resources available percentage of economically usable water resources is 21.7 billion cubic meter, and percentage used is 52.52% has already been used. The state has a total economically usable water resources in the state is 45.09 million cubic meter, and out of which the percentage which are used is 79%. Changes in the groundwater potential have been noted considering different years in 98, 2004, 2009 and 2011. When we see the domestic and use of groundwater resources in the state, we find that in 98, 69%, the stage of development, in 2004, 125, in 2009, 135%, and in 2011, 130% of the development of the groundwater resources. So this is the situation of groundwater resources in the state. When we analyze the temporal change of groundwater, because there are 243 development blocks in the Rajasthan, and this is the continuous change, 1984 to 2011. In 1984, 203 was safe development blocks, and that has reduced to 25 only in 2011. And the overexploited block has reached to 172. And now the recent study that has indicated that it has exceeded to 205 development blocks out of 243 development blocks are under a severe stage, critical stage. They have been overexploited. So this is the spatial distribution of groundwater development. As I indicated, that overexploited blocks in the state are nearly 172. And stage of development also reached to 135 as indicated, but now it has reached to 171. Another problem which is related to water resources of the Rajasthan is the groundwater quality, because there are a number of problems: presence of fluoride, salinity in the groundwater, nitrate, iron, and arsenic problem. Arsenic problem is not very important in the state of Rajasthan, but fluoride, salinity, nitrate, these three important elements are very, very much, and the areas which are affected by these fluoride is nearly 39% villages are suffering. Salinity problem, 82.42% villages of the state are suffering. And nitrate, 22.62% of the nearly 49,000 villages are there in the state. And out of that, 22.62% villages are suffering from nitrate problem. So this is the situation so far as the quality of water resources are concerned. And this is the spatial distribution of excessive fluoride problem which is available in different districts that has been plotted. Because there are certain areas where the fluoride content in the groundwater is exceeding 15 pp. So this is a very important issue in the state of Rajasthan. As I indicated, the scanty and irregular rainfall trend from 2001 to 12 have resulted in poor recharge of groundwater. Climate change projections in declining rainfall and increasing mean temperature in future will further limit the recharge of groundwater resources. Indiscriminate use of groundwater has brought out changes in quality like fluoride, nitrate, and TDS, making groundwater unsafe for health. Climate change will further increase groundwater extraction due to less availability of surface water and rising demand, which could further deteriorate groundwater quality and have a serious implication for human health. The efficiency of water use in the state is low, and unallocated for water loss is very, very high. About 2/3 of the water used for irrigation is affected by inefficiency. Losses of surface water irrigation are much higher as compared to those in groundwater irrigation. Hence, Rajasthan needs more holistic and integrated management of the water resources. Collective action is necessary to bring together all sectors and stakeholders to work together towards integrated and participatory solution of water resource planning and management in view of climate change. There are some critical issues which are related to water resource management, the growing imbalance between demand and supply of water, uncertainty in availability of water, inequity in access to water, low operational efficiency of water resource development projects, depletion groundwater resources and deteriorating quality of water, high cost of service, low cost of recovery, and low level of expenditure, and lack of ownership among stakeholders. So these are some critical issues, and radical shift in policy is needed. Allocation priority should be, because in 2010, a groundwater policy, water policy of the state has been brought out. In this, priorities have been given to human drinking water supply, livestock drinking water, other domestic, commercial, and municipal water use. Because in earlier time, there was more emphasis on irrigation, use of the groundwater resources, but now in 2010 onward, government has started giving new priority to human drinking water, and agriculture, power generation, environment, ecological issue, they have been at a lower side. So highest priority in the new water policy is on human and animal drinking water facilities. Now in Rajasthan, because Rajasthan has been adopting traditional method of water conservation in this desert state. So the traditional method of water conservation are very important, and it again needs to regenerate these things. And step wells, Bawris have always occupied a central position in all communities in Rajasthan. In western part of Rajasthan, tankas, johars, nadis, khadins are used for community or private storage of water. Tankas are privately owned, while Bawris built privately are open for community use. Diggy wells, reservoirs, and step wells for public use was a philanthropical activity. More than 3,029 step wells and step ponds in 33 districts of Rajasthan are available. So there is a need to regenerate traditional water harvesting system in order to mitigate the problem of water resources in the state. Earlier days was significant, but in course of time, their importance has lowered down.
Sir. We are running out of time. Thank you, sir.
Yeah.
Sorry to interrupt. Actually, we are running out of time, and it is time for the next speaker.
In 1 minute.
Yes, sir. Please, sir.
I will conclude in 1 minute. So, what to do? My suggestion is that an exploding population will continue to build pressure on land and water due to climate change. This would hasten the vegetal degradation by increasing demand for fuel wood and others. Therefore, it is necessary to readdress the use of water resource management at 3 stages. Judicious use of available water resources, development of recharging methods, particularly water harvesting system, and third, regulatory measures to utilize limited water resources. There is a need to adopt conservationist approach than exploitative approach for sustainable development of water resources. Thank you very much for patient hearing. Thank you very much.
Thank you, Mr. Sharma, for your very interesting presentation. And now I pass the word to Sergey Chalov. He is Associated Professor of Hydrology Department of Faculty of Geography of Moscow State University. Please, Sergey. You muted your microphone.
Okay, good evening, good day, everyone. Good to hear, good to see, and I had some problem with the video. Now that's hopefully fine. I'm very happy to have such kind of meeting in this even remote type of discussion. I've been to Delhi 3 years ago for World Large Rivers Congress, and actually have some nice experience in discussions with Indian colleagues. So that's good to have new road in this direction. So this, I would shift our meeting to the north, and it's good to start with that can be interesting for you. That's even so there is very now limited situation in terms of traveling, but we just came back a few days ago from actually these rivers, which I will talk about, also together with Sevold Moredi, who is also participating in this meeting. And we've been 11 hours flight from Moscow to this Kolyma river, which is very northeast of Russia. And that's in some way my talk will be very, in this regard, very timely. Based on our recent field work. But of course, I would rely more not only on this recent results of the field studies, but I would, do you see my presentation? No?
No.
No, okay, I would try to make it again.
Sorry, we are not able to see the slide.
That's okay now, right?
Yes, now it works.
Excellent.
Oh, okay.
So, and this is actually, so I just show you the first picture with this photo from the Kolyma River, which I mentioned, and I would continue with the general approach, what we are studying on that. So it's we are focusing on the study of the largest rivers. So actually the largest rivers of Russia, which is 4, we call it Arctic pillars, which drain from the huge territory of Russia to the north and deliver a huge amount of sediments and chemicals into the particularly polar or Arctic Ocean. And the idea of this study is that it's the integrated nature of the this chemical flux, which is driven by the hydrological and hydraulic factors, which sort the sediments and then make a very important impact on the structure of the flux. So that typically the problem is that the typical monitoring is not reliable to understand all the structure of this flux in the river system, and also to understand the sources, which mostly the catchment erosion and bank erosion. And there is only a few examples in the world of the kind of more integrated studies which rely on both hydrological and hydrodynamic factors. And so here I mentioned the very, let's say, famous in this hydrosedimentological environment study, which was done on the Ganga River within the last 10 years. And this study was related actually to this integrated, comprehensive nature of to study the river in flux. And in some way, we were also in kind of looking this experience to set up the studies of the Arctic rivers. And so I would say that this Ganga River and Amazonka River, it's only the two rivers where the two large rivers in the world were really sort of sequence from the hydrology to the hydrogeochemistry was set up in very integrated nature. So that's also good to mention in our Russian-Indian meeting. And so I go forward to actually the problem which is relates to the study of these Arctic rivers. So that's the huge territory and the huge amount of the flux. It's like 58% of the terrestrial water flux coming from the Russian Arctic. And this huge amount of water is carrying a huge amount of the sediments and of the chemicals. And this flux, I mean, if the water is monitoring quite well, so the chemicals and the sediments monitoring is really a big gap. And then we're taking these four largest rivers, Ob, Yenisei, Lena, and the Kolyma, that I said it's like a pillars. We proceed with the field-based monitoring campaign, which was relied on the 4 outlet stations in these largest rivers. And for the last years, our Faculty of Geography of Lomonosov Moscow State University, together with the Institute of Water Problems of Russian Academy of Sciences and the local partners, set up rather novel and comprehensive monitoring campaign with 2 sets of the activities. The one is this black points is the stations where we make a monitoring. The red squares is the delta buffer areas where we set up the specific remote sense-based study to see how much sediments and chemicals are stored in these deltaic areas below the outlet stations. So, and that's the project itself was called Arctic Flux. So just clear why the name coming from, and it includes different models. I would in this short talk just briefly mention the main maybe approaches and main ideas of all these work packages to see what is the integrated sediment and chemical budget is constructing in this big area. So that's the measuring of the monitoring campaign. This is the conceptual model to kind of particulate metal flux and the transformation of the flux in the deltaic area. So as far as we are field-based study, that's the 4 gauging stations were initiated on each of these rivers in the most, as I said, downstream areas. So it's the Ob River is the city Salihat, so the same in Yenisei, the city Igarka. In the Lena, it's Zhigansk, and in the Kolyma River, it's Chersky, where we've been just last week, as I said. And to make an illustration of the importance of rather detailed campaigns and links to hydrology, I would show this photo which came from the last week experiments on this Kolyma River. So you could see that's the filters which were in the cross section of the Kolyma River from different profiles, and these profiles are shown in the graph here in the right up corner. And this is how the surface water looks like, or surface sediments looks, and here how the near bottom sediments looks like. And as you can see, that's this clear, even visual change in the sorting of the sediments is associated with this huge change in the sediment flux. And if we, for example, sample some of each of these certain locations, we would have very unclear or very unreliable knowledge of what is really the concentration of sediments or the concentration of chemicals is. And that's the main challenge to the study. That's we have 3 kilometers width of the river, and within this river we need to find some solutions to sample or to have enough strategy to sample these very broad or very different type of the matter. And here we include and rely on the very important novel technology, which is this, which is called ADCP, or Doppler profile measurements. And we put here the idea that both with the velocity profiles, which is coming from the ADCP sensors, we can get the precise estimation in each cell of the sediment concentration. And together with these grep samples in each of the points of the profile and ADCP measurements, and using specific hydraulic parameters like Krauss number, I have no time to go into detail, but I would just briefly say about the idea that we come up to the integrated understanding of the distribution of the concentration within the whole profile and in each cell, which is like centimeters width, in this large river system, and end up, based on the different types of measurements, with the whole picture of the concentration of sediments in every small part of the channel profile. And from this information, and you having for the last few years few field campaigns at each of the river, we are able to find the links between the total sediment yields and the water discharge to obtain the annual sediment fluxes and compare it with the catchment and channel erosion to calculate the whole budget of the river system, which is generally that's the main output of the study. And further compile it with the chemicals analysis to come to the understanding not only of the total sediment flux, but also of the total chemicals flux with particular element sorting. And here the very important thing is this kind of pictures that the different chemicals are distributed in the range of the profile quite depending on the grain sizes. So that's bring us to the decision that having the information about the concentration, the grain sizes, and the chemicals in different time sets, we can go to the understanding of how the flux, annual flux, is formed. And the last part in all these approaches is to see what is happening in the near coastal area, in the most downstream area below the outlet stations. And here we have the big deltas like Lena Delta, which is the hugest, second hugest after the Amazonka in the world. And it's not possible to establish any kind of the field-based studies. And here we rely on the sediment remote sensing data sets and provides this special technology to map sediment concentration and calculate sediment budget based on the satellite images. So on the land side, it's quite well, both in terms of the temporal resolution and the spatial resolution. And we got kind of the spatial distribution of the sediment concentration. And here I just briefly mention one very nice example of what we can learn from these approaches. It is the very unusual graph which shows the relationship between the sediment concentration change along the delta and the temperature, air temperature. And as you can see, there is the positive correlation for different branches exists between the change of the sediment concentration. So it's just simply the difference between the sediment concentration in the upper part of the delta and the outlet part of the delta, which is depends on the air temperature. And this air temperature means that the main driver in these northern areas is the melting. So the higher the air temperature, the bigger thermal erosion we have, the more sediments are eroded and the more sediments are washed into the river. And we have this kind of very unexpected relationship between sediments and the temperature. And this brings us to very important knowledge about how the flux is transformed in the main near coastal area. And then we get, so I can shortly say about some outputs of the study, but in general, it's my idea was, and our idea was to show these examples of the approaches related to counting the large river flux, which is quite new in hydrology and challenging in the channeling hydrology studies in the world. And yes, in this I would finish. Thank you for your attention.
Thank you very much. So our next speaker is Professor A.C. Rai, who is Secretary General of the National Association of Geographers India, NAGI. He is basically an expert in the land and water resource management, and he will be talking on water quality assessment of wetland ecosystem in the Indo-Burman hotspot. Professor Rai. Due to short of stage of time, we are not able to do the question answer session. Maybe we'll think about some alternative channels through which we can try to answer the questions of the audience, and which will pass through either through website or any other option. Thank you. Professor Rai.
Yeah, thank you very much, and good afternoon to everybody. Now, I have little bit modified my topic, and the latest is wetland degradation, its driving forces and environmental impact in the Indo-Burma hotspot. This is the very peculiar lake, very important lake, which I am going to present my data and analysis and research. So, India is one of the 12 megabiodiversity countries of the world with Western Ghats and Northeast region as the two. Hello.
तो ये आवाज आपकी ब्रेक हो रही है.
ठीक है, ठीक.
Hello.
हाँ, बोलिए, बोलिए, ठीक है.
Yeah, I'm audible.
Yeah.
Okay.
Yes, it's okay now.
So, the 12 megabiodiversity countries of the world with Western Ghats and Northeast region as the two identified global hotspot of biodiversity. So, in this two biodiversity hotspot, I have selected this Northeastern region hotspot. And this lake is situated in the Manipur state, which falls at the juncture of two hotspots, namely Indo-Burma hotspot, which is one of the mega biodiversity hottest hotspots, and Himalayan hotspot. And this figure gives you the this whole world biodiversity hotspot, and here I can show this Manipur. This and Myanmar, Laos, and Thailand, Cambodia are this. So this is one of the most important hotspot of the world. Population growth, urbanization, and industrialization are the major driving forces leading to change in land cover characteristics and subsequent hydrologic processes, specifically through the large-scale conservation of forests to other land uses. And substantial change in land use land cover have occurred over northeastern part of India in the past few decades with the shortening of zoom cycle, spread of settlements, and increased use of land resources for agriculture and economic development. So keeping all these problems in my mind, so I have framed three objectives: to study the impact of human activities and land use land cover change on the lake ecosystem, then to analyze the changing characteristics of the lake with special reference to water quality, and third, to identify appropriate measures for better management of the lake ecosystem. So if you see this slide, this will give you the clear idea about the distribution of the lake in Manipur state, and this one is the Loktak lake. And percentage of wetland in Manipur, if you see, so 62% is lake and ponds, 6% waterlogged area, 26% river and streams, then 1% reservoir, whereas aquaculture pond 4%, and wetland less than 2.25 hectare, mainly tanks 1%. So this is the scenario of the wetland in Manipur state. So government of Manipur identified 19 lakes for its conservation. So out of these 19, I have selected this Loktak lake for detailed study. This is the Loktak lake, and the beauty, this will give you the satellite view of the Loktak lake, and this is the panoramic view of the Loktak lake. The beauty of this lake is its biological richness and uniqueness of habitats has resulted in its designation as a wetland of international importance. Under the Ramsar Convention, it distinguishes its share with just 5 other lakes in India. So this is the Ramsar site and very important lake in India. And if you see in these photographs, you will find this the island type situation. This is the national park. This park is called Kebul Lamjao National Park. And the total area of the lake is 287 kilometers square, and depth is 0.5 to 4.6 meter. And if you see the morphometry of the lake, the maximum length is 26 kilometer, maximum breadth is 13 kilometer, shoreline length is 126 kilometer, orientation is north-south, surface area is 287 kilometer, area covered by island 17.2 kilometer square, and area of open water is 73.5 kilometers square. So total volume, maximum depth. So this will give you the clear idea about the morphometry of the lake. I'm coming to the first objective, how land use land cover change impacting the lake ecosystem. So if you see this, I have taken 1990 years data and 2004 years data. And if you see the variation in this land use land cover, you will find only built up land and open forest area is increasing. All other land use categories are decreasing at the cost of other land use. So, and open forest is increasing because of dense forest is decreasing. So this is the actual figure of the land use land cover change in the local lake catchment. And if you see this slide, information are urbanization and forest. So social forest, total forest coverage is in 2011-13, and decadal increase in population 2001 to 11. So forest cover decreased by 180 square kilometer between 2009 and 11, and 100 square kilometer between 2011 and 13. So if you will see what is the pressure in the forest area in that region, and district wise forest area and urbanization rate is given. Urban population has been increasing at the rate of 42.7%. Demand of water supply is increasing, but the existing availability is 78 liter per capita per day. So this is the very grim situation in the water side. This will give you the clear idea about the Jhum cultivation in Loktak lake watershed. This is the practices of Jhum cultivation, and this is the major problem of the eutrophication of the lake in Loktak lake in Manipur. So Jhum cultivation, if we are not going to stop Jhum cultivation, we are not going to solve the problem of the lake sedimentation and eutrophication. Hydrological impact. Water regime of Loktak Loktak Lake is determined by the inflow from various streams and direct precipitation on the lake surface. Overall, 34 streams from the Western Hills and the Manipur River via Ungamel and Thogredek channels drain into the lake. Water inflow and outflow. Water regime of Loktak Lake is determined by the inflow from various streams, direct precipitation and lake surface. Then total annual inflow of water into the lake was 1,687 million cubic meter. And the total outflow of water from the lake was estimated as 1,270 million cubic. So only 470 million cubic water is stored in the lake. There has been a drastic change in the water exchange pattern between the Manipur River and Loktak Lake after construction of the Ithai barrage. The inflow was reduced to 91 million cusecs and outflow to mere 20 million cusecs. So, due to construction of the Ithai barrage in Manipur River, the inflow and outflow of the lake water is very reduced. Inflow of nutrient from major river into the Loktak, and if you see, these are the major river in the Manipur: Nambol, Awang, Khurjok, Thangjok, Khordak, and Postdang. So Nambol and Nambol, these two rivers are very polluted rivers. And if you see the nitrogen, phosphorus, and potassium, so nitrogen, Nambol contribute 2,338 ton per year. Nitrogen, 270 ton per year phosphorus, and 2,081 ton per year potassium in the lake ecosystem. And Nambol is 243 ton per year, nitrogen 34 ton per year phosphorus, and 198 ton per year potassium. So this slide, this picture gives you the clear idea how different rivers polluting the lake ecosystem of the Loktak Lake. Sedimentation. Loktak Lake is gradually silting, and the major contributor is sediment from the surrounding catchment. And why? Because of due to shifting cultivation. The annual average sediment input into the lake is estimated at 650,000 metric tons. Out of 45 micro watersheds of the western catchment, Thangjok yields maximum sediment load of 58 ton per hectare and the minimum of 2 ton per hectare by Merakhong. It has been observed that the silting rates have increased by 34.44% during 1993 to 2003 and by 69.94% during 1967 to 2003. So you see this around 70% this silting rate is increased from 1993 to 1967 to 2003. High sediment deposition in the lake turns the lake turbid and deteriorating water quality. Now I'm coming to the water quality. Some physicochemical parameters like temperature, pH, turbidity were analyzed and recorded on the spot immediately after collection of the water sample, while the remaining parameters were collected and preserved and brought to nearest laboratory and were analyzed within 24 to 72 hours following the standard method of Etan et al. 1995. So the result of the parameters were statistically analyzed using SysStat software. Statistical analysis between site and seasons was based on the analysis of variance ANOVA, and that of correlation among various physicochemical parameters was based on Pearson correlation coefficient analysis. So this is the Loktak Lake, and this lake is divided into 3 zones: northern zone, central zone, and southern zone. And from each zone, I have taken the sample from 2 points from different zones. So out of 3 zones, we have collected 6 sites for water sample for quality analysis. If you see this slide, pH, turbidity, temperature, conductivity, free carbon dioxide, alkalinity. So the most of the selected parameters reflected that seasonal pattern showing higher value in the rainy season. If you see all the parameters, in rainy season you have find the highest value in all parameters. And the dissolved oxygen, if you see this, dissolved oxygen concentration ranges from 6.8 to 9.32 milligram per liter. Oxygen content in bottom layer is lower compared to the surface, indicating the eutrophic nature of the lake ecosystem. So now I'm coming to the conservation measures towards conservation of the wetland in Manipur, the feasible way. Number 1 is proper and legal demarcation of the boundaries commonly accepted to the government and the surrounding local people. Because why I am telling this? Because in Manipur, there is a conflict between government and local community regarding the ownership of the land. So there is a urgent need of legal demarcation of the lake boundary. Stop draining of lakes. Desiltation using various means, machine-based or traditional ways. Biodiversity conservation. And water quality monitoring and conservation. There is a need of seasonal and regular basis water quality monitoring. So the people can know how much water quality is deteriorating and what step we are going to take. So a long-term catchment improvement program should be run in this lake ecosystem, so we can save the lake, Loktak Lake, for sustainable manner. This is the give you the clear-cut idea about the life of people in Manipur. This is the Loktak Lake, and this is the fishing, because the people, surrounding people, is dependent on the fishing for their daily survival. And the mission is to sustain and restore wetland, their resources and biodiversity for future generation through research, information exchange, and conservation activities worldwide. This is our mission to conserve the lake ecosystem. Thank you very much for giving me the opportunity.
Yes, thank you. Thank you very much, Mr. Rai, for your very interesting presentation. And I would like to pass the word to Ekaterina Ivanova. She is the scientific researcher of the Complex Limnology Problems Laboratory, Institute of Limnology of the Russian Academy of Science. Please, Ekaterina.
Hello, dear colleagues. Can you hear me?
Yes, yes, yes.
Okay. So I would like to present our new study. We started just maybe last several months. It's a new topic, and it concerns microplastic research in intercontinental water bodies. So just a second, I share the presentation.
ये हटाओ कैसे हटेगा? यहाँ से? ये? नहीं.
Can you see the presentation?
Yes, yes.
Okay. So I want to say that the scientific society realized that microplastic pollution is a big problem just last time, maybe several decades. But nowadays, and more scientific groups all over the world make different kinds of research concerning this problem. So a few words about what is microplastics. So microplastics, it's a particles of plastic less than 5 millimeters. They can be primary and secondary. Primary microplastics, it's granules, and they made in cosmetics and household chemistry. And secondary plastics are the product of destroying bigger plastic fragments to smaller ones. So unfortunately, nowadays, microplastic particles present almost in all environmental components. So you can see here that plastics can go to the water objects directly by wastewater, and also these particles go to soil and can accumulate in soils, and they are even found in groundwaters. Small particles also can spread by wind. So last time, many research groups study microplastic influence on organisms. And now we know that plastics contain different harmful compounds, for example, phthalates, bisphenol, and others. These compounds can have toxic effects on organisms. Also, we know that microplastic particles absorb very good chemical pollutants on the surface, and also can be consumed by organisms. And the plastic particles are covered by biofilm in water and can transport different microorganisms, including pathogenic ones. So what about our research? We make a research in two big water objects. They are Ladoga Lake and the Gulf of Finland. So these two objects are situated near St. Petersburg city. Ladoga Lake is the biggest freshwater lake in Europe. You can see it here. This is Ladoga Lake. And the Gulf of Finland here, it is very high populated area, and it's very high eutrophied water body. These two objects are connected with Neva River. So mainly we study water samples from these objects, then we study sediments and ice. So here you can see different devices to sample water in different seasons. So here you can see the scheme of sampling in the Gulf of Finland. We do it by international methods used for Baltic Sea region. And also you can see bottom sediment sampling from ice cover of Lake Ladoga. After sampling, we make some procedures for sample preparation, and at the end, we analyze sampling in the laboratory using international methods. And after it, we analyze particles by optical microscopy and different kind of spectrometry and fluorescent microscopy to verify that the particles are microplastics and identify type of the plastics. So a few words about results. So you can see how look samples in optical microscopy. So in water samples, mainly we found fibers like this one, and also granules of primary microplastics. So the main results for Ladoga Lake, we have a lot of monitoring stations on Ladoga Lake and catchment. And 2 years we took samples there, and now have some first results. We can say that mean concentration is about 1 particle per liter, but Ladoga Lake, it is very clean water body. So for example, in the Gulf of Finland, we have very different picture. Here you can see the results of microplastic content in sediments at water edge and in bottom sediments. So the content of microplastic particles in sediments are significantly exceed the concentration in water samples. So these preliminary results show that the possible importance of bottom sediments is accumulation hotspot of microplastics. At the end, I can say that international research of microplastic pollution is very important and can be very useful. So it could help to understand ways of transportation and transformation of these particles and in environment, and maybe study this in different environmental matrices, including groundwaters, that maybe can be interesting for Indian colleagues. And also it could help to understand the ways to prevent some dangerous consequences of this problem for ecosystems. So thank you very much.
Thank you, Katerina. So while I have to say that I see the translation of our meeting in the YouTube, and there is a huge amount of the replies. And yes, Ekaterina, personally to you, Indians, our colleagues from India, they are very, very happy really. And they say to you, thank you for your presentation.
Thank you very much.
So, Mr. Saha.
Yeah. So, okay. So we will move on to the next presentation by Professor Roli Kanchan. Professor Roli Kanchan is a professor at MS University, Baroda. So we have tried to bring people from every corner from the country. So she's from the western part of India, Gujarat. She's a regional, she's expert in regional development and planning and geography of health. She has a lot of publications in her credit. So she'll be talking about assessment and management of aquifer vulnerability, prospect and challenges. Professor Kanchan.
Good afternoon, everyone. Till now, we have been talking in terms of the surface water, but my research is largely on the groundwater and or subsurface water, and I feel that as far as subsurface water or groundwater is concerned, it is an important indicator or an important water source, largely because it has relatively low vulnerability. Can you hear me? Can you see the slides, son? It's okay, Professor
Yes,
Saha?
everything fine. Perfect,
Okay.
perfect.
So it has relatively low vulnerability, and at the same time, it's a very large source of water. That is why I would be concentrating, and my research is also on the subsurface groundwater. And the topic for which today I've taken is on the modeling of the subsurface water. And I would be talking on the assessment and mapping of aquifer vulnerability. Now, as all of us know that groundwater is a vital source and it is considered to be safe, largely particularly in a country like India, where the surface water is contaminated. In that particular context, the subsurface water is considered to be safe, as well as far as subsurface water or the groundwater is concerned, it is definitely a major source of drinking, irrigation, industries, etc. But subsurface water has got lots of minerals in it, which gets mixed with the aquifers and the minerals which are there. Hence, but the WHO and even the BIS has got certain standards, and any mineral contamination or the mixing of the minerals in this subsurface water, if it is more or below, then only it becomes an issue. But I'm talking in terms of the modeling of the vulnerability, and because as far as the contamination is concerned, that is a different aspect altogether. And although I have worked on it, but today for today's lecture or interaction, I thought that I would undertake modeling as my research topic. So, in fact, when you're talking in terms of the models, many models have been taken for the subsurface water. Say, for example, GOD is taken, and when you are talking in terms of GOD, then it's a overlay and index method, and basically the three parameters which are taken is the groundwater occurrence, overall aquifer class, and depth of the groundwater. This was, as you can see, that it was propounded in 87, and Foster was the proposer of this model. The other model which is commonly in use and is the syntax method. And the syntax model is an extensively used method for the identifying the areas where groundwater supplies are most vulnerable to the vulnerability. And as you can see, the parameters which are used are groundwater table, actual infiltration, and so on and so forth. The next parameter which is used is AVI, and in the AVI, basically two parameters are taken. One is the thickness of the sedimentary unit, that is the uppermost aquifer, and the estimated hydraulic conductivity of each of these layers. But I have been working on the drastic model, and this drastic model has been proposed by the US Environmental Protection Agency, and the seven, and it has been, and the seven parameters have been used in this drastic model. Now, the reason why I have taken up this drastic model is that it is more, a model is robust. The seven parameters which one has to take are all parameters, and it is integration with GIS, and the rates and the weights are already calculated for different types of the regions. So that is why I have taken drastic model. The drastic model has seven parameters, as I said: depth of the water, recharge, aquifer media, soil media, topography, impact of vadose zone, and hydraulic conductivity. It is a very simple equation where the rates and the weights of each of them are multiplied and added to each of it. And hence the equation or the mathematical calculation of it is also very simple. The assigned weights, which are by the US EPA, is the depth of the water is given the highest weight of 5, and similarly the impact of the Vadose zone is also given a very high weightage of 5, and the least is of the topography. So the weights which are assigned vary from 1 to 5. Similarly, the rating system, as I also mentioned earlier, was also already assigned, where the less than 5 is 10, 5 to 10 is 9, and so on and so forth. So one has to multiply the weights and the rating system to get the equation. So it's done like this, that the entire data is from the secondary sources. Then the data which is gathered is then manipulated. Then each of them are used, the maps are generated on the basis of the rate and the weight. And all these 7 parameters are first assigned different maps. And after them, with the overlay technique, the drastic model is generated. Now, as far as these parameters are concerned, there is a reason and a logic for each of them. As far as the depth of the water is concerned, it is an important parameter because it determines the time taken by the contamination before it mixes with the groundwater. And greater the depth of the water or the groundwater, the travel time would be more. And when the travel time would be more, then it is believed that the contamination would be lower because there would be a loss of the contaminants. The second is the net recharge rate, and it is defined by the total amount of water that penetrates through the groundwater, whether it is from the precipitation or with the surface water or any other source, whether it is a lake or a river or anything of that sort. And the rate of recharge increases with the increasing precipitation and the availability of the surface water. The third parameter is the aquifer media, and it is the characteristic of the aquifer which also decides about the percolation of the water. And this is an important thing, and because whenever the percolation is there, it is defined by the aquifer media. Say, for example, if it is a clay, then the mixing would be more. If it is a silt, then the contaminants would reach up to the groundwater much more easily. The next parameter is soil in the drastic model, and it is the first layer where the infiltration which infiltrates from the surface. And as the soil texture becomes finer, the space between the soil particles decreases and the rate of infiltration also decreases, and the vice versa. Topography does not play a very important role, and that is why it is given the least weight. The next is the impact of the Vadose zone, and it is an unsaturated zone between the surface and the groundwater table. And the condition of the Vadose zone is quite complex, as the geochemical condition of the region and the transport of the contaminants play an important role in determining the condition of the groundwater. And the next one is hydraulic conductivity, or the last one I should say, and it is the capacity of the water to transmit water from one place to another. It is a significant parameter as it is associated with the rate of flow and the movement of the contaminant. I have used these drastic models in 2 cases. One is in Gujarat itself, and this is an area nearer to Baroda, which is an industrial area. And another And the other
कल से ही मेरा हैक हुआ है। हाँ, रेडिट भी हैक हुआ। हाँ, ये गलत दिखा रहा है। ये तो फेक मेल है, ये फेक मेल है।
And the other area is the West Bengal area, where where in fact the arsenic is a big issue, and that is why I have used this model, one for the industrial area, and the other is where there is lot of arsenic contamination in the groundwater, and because of these two conditions I have taken this, I have proposed this drastic model. And both these areas, because topography also does not play a very important role in the district model, and that can be considered as a limitation of this study. But both these areas are plain areas, and that is why it will not take, it does not matter much. Now, in the first study, which is, as I was pointing out, this is industrial area where there are large number of chemical industries, and this is known as adjoining area of Gulf of Cambay, and Bharuch and the Surat districts are encompassing it. Now, when I proposed this study, then in fact the aquifer media, the impact of the Bozrol zone, and topography were not playing any major role in these three were not playing a very major role, and they all had a low vulnerability index, largely because it was a coastal area. So here you can see that as far as the topography is concerned, there is not at all much variation. Impact of the Vador zone is concerned, it is also almost similar. And as far as the aquifer media is concerned, except for slightly these two parts, you find that there is a lot of similarity. In terms of the hydraulic conductivity and depth of water, both of them had a higher vulnerability. And in fact, as far as the hydraulic conductivity is concerned, the entire area had a higher conductivity, and this is largely because of the reason that it is there nearer to the coastal areas. But in terms of the net recharge rate and the soil, one can see that there was lot of variability was seen, largely from the lower to the higher. In terms of the net recharge rate, the southern portion had the low index, and the vulnerability went on increasing towards the northern part of the study region. The lower vulnerability in the southern part was largely because here you have many rivers like Tapi and Narmada. But now imposing everything on it, then talking in terms of the vulnerability zone, then the vulnerability in the central and the northern part was highest. When you're talking in terms of the central part, and towards the northern part, the vulnerability was very high. And this region has a Surat industrial belt, and this region lies between the interfluent of the two major rivers of Gujarat, that is Narmada and the Tapi rivers. And north of the Narmada river, here you find the Narmada river. It comprises of the industrial belts of Bharuch, Ankleshwar and Dahej, where you find a large number of chemical industries. And in the southern part, you will find that the water quality is better, and because the index is relatively low. Now, the same model was applied to another area, which is in the West Bengal, and this area is basically is vulnerable to the arsenic contamination, and that is why it was done for this study, and Murshidabad district was taken. And here the two major rivers which are flowing are in the central part of the district, that is the Bhagirathi River. And then putting all these again in the same platform, it was seen that as far as the depth of water is concerned, the area has a lower vulnerability. As far as hydraulic conductivity was concerned, it was almost nil. As far as net recharge rate is concerned, that was also very low. As far as topography was concerned, it's a plain area once again. As far as aquifer media is concerned, the eastern half had a lower vulnerability as far as the western half is concerned. But as far as the Ebedos zone is concerned, then the southern part of the district had a more vulnerable than to the northern part. And now superimposing upon it, then one can see that the highest vulnerability and the higher vulnerability was in the eastern part of the district. Now, it was seen that on the east of the Bhagirathi, there was a highest vulnerability and of ranging from 160 to 180. In the western portion, it was between 150 to 159. And the highest vulnerability of 180 plus was found in the north central portion and in some discontinued patches in the southern and the western tip of the region. Now, the moderate vulnerability was found in the western portion and some patches in the eastern part. Now, if you see to the entire area, then almost 20% of the 1/5 area of the district had a least vulnerability, 10% had low vulnerability, more than 50% of the area had moderate to high vulnerability, and the highest vulnerability index was found in the 14.13% of the total area. Now the challenges is the availability of data that should be there, availability of timely data, and all the models have a limited numbers of parameters which are involved. There can be much more parameters. And the second thing is that this type of the drastic model is more appropriate in the plain areas rather than in the hilly areas. And on this note, I can say that it is not the end, it is the beginning. The future towards this can be artificial neural network, and the simulation models can be prepared to know the groundwater vulnerability. Thank you.
Thank you very much.
Yes, thank you very much, Ms. Kanchan. And I would like to pass the word to Vladislav Polyanin. He is the Deputy Director of the Water Problems Institute of the Russian Academy of Science.
Thank you, Elena. Something go wrong? Sorry. Could you see my presentation, dear colleagues? Oh, okay. I'd like to start with some pictures that was taken more than 100 years ago. You know, floods are among the main threats to water security in Russia. And all over the country, they may vary in size, reasons, and consequences. But for European part of Russia, where our capital city Moscow is situated, the main hydrological event is a spring flood. One example is captured on these hotas. That was the most devastating flood event in the Moscow region had ever seen before, and was caused by coincidence of sharp rise in temperature, intense snow melting, and heavy rainfall. The maximum water level in the Moscow River rose up to 9 meters, and the river water discharge peaked up to 2,800 cubic meters per second, while in ordinary conditions, especially in low flow periods in summer, it can fall down to only 10 cubic meters per second. And the region used to be mostly affected by the severe floods approximately every 15 to 20 years. And the situation had never occurred since the system of interconnected dams, canals, and water reservoirs was constructed in the 20th century. This system consists of 3 structural parts based on water resources and hydrotechnical facilities of the upper Volga River, with the largest water reservoir, Ivankovo Reservoir, the channel of Moscow, 128 kilometers long, the Moscow River system, and the Vazuza River system. The functioning of this system implies accumulation of a part of the spring flood to smooth out extensive water levels, sustainable drinking water supply, providing ecological flows, and power generation. Something went wrong. I'm sorry. No. You know, the main regulation rule is that water reservoirs must be filled up during the period of spring flood to ensure water supply the rest of the year. But in recent 20 years, the climate change have been affecting the redistribution of the river flow volumes from the spring to summer months. Declining flood volumes seem to be more obvious along with the rise of peak rain flows that often exceed the maximum water discharge during snow melt. And this graphs depicts the situation, up-to-date situation, with almost no flood at all this year. And very poor long predictability of rain events against the background of filled water reservoirs at the end of spring increases risks of emergency related to high waters. The situation has continued to worsen in recent decades with the real estate development on the banks upstream the dams, as well as on floodplains downstream the dams. It means that the areas which had been designed specifically to hold flood water is now have property on them. Combined with natural factors, with climatic change, it poses serious impediment to water resources regulations. Here are some examples of harmful human activities within drainage basin of the Moscow River. Here are headwater development, sewage water, combined sewage water overflow, some improper disposal of manure from agricultural activity, development of the bank river on the riparian areas, and illegal landfills. So here are some reasons and their consequences to environmental instability within the Moscow River watershed. Untreated wastewater effluents, land misuse related to diffuse pollution, building up riparian areas, the lack of ecological awareness among local people and authorities, and climatic change that lead to water pollution and degradation of water bodies, reducing self-purification of waters, high concentration of pathogens and algae blooms in water reservoirs, and reducing predictability of river runoff. Some examples of negative effects on water quality. Here are the picture of Mozhaisk water reservoir, and you can see that on about 8-meter depth, there is almost no oxygen, dissolved oxygen in water. So here is a picture of algae blooms at the intake at the Western Water Treatment Plant in the Moscow River, especially high levels of blue-green algae in September, you can see here, and high bacteriological contamination of water downstream the dams. And what to do to ensure drinking water quality standards at this local level? We need long-term strategy for pollution abatement and improvement to the state of water sources based on enhanced and clear water protection legislation, first of all, monitoring and strict control to human activities within the watershed. We need the management of hydrologic regime of water reservoirs and overall control of water resources distribution and use based on up-to-date methods of hydrological modeling and forecasting. And of course, we need to enhance our flexible and comprehensive technological scheme of water treatment at our water treatment stations. Here are some examples of the monitoring system within the watershed of the Moscow River. And key points of successful monitoring here is dense network of daily observation sites, trained sanitary inspector and laboratory staff, flexible monitoring projects using additional up-to-date methods like drones, collaboration with environmental authorities, officials, and scientific support. And this is an example of advanced technologies of water treatment that are used at the Moscow River water treatment plants. They include advanced methods of water treatment, such as ozonation with activated carbon and membrane filtration. And about 1/3 of all the waters that come to Moscow River treatment plants are treated like this. And now I'd like to shift to another scale of the problem. Here is the Volga River, the largest river in Europe, with a total catchment area more than about 1,360,000 square kilometers. And this is an example of recent, very large recent project that aimed to abatement of diffuse pollution. There is another main threat to water security in Russia and pollution of water, and the Volga River is the total number of cases within the Volga River catchment of high and extremely high pollution of surface waters is in river basin in recent years amounted to 1,000, which is about 30 or 35% of the total number of registered cases in the Russian Federation. Traditionally, the main factors affecting water quality are considered to be insufficiently treated industrial effluents and municipal sewage systems. In this regard, until recently, the regulatory actions of water protection in Russia have been the management of discharges and the reuse of wastewater. That is the management of point sources of pollution. However, despite some progress in that direction and the overall decline in wastewater discharges, partly as a result of the decline in industrial production, such as one-sided approach had no result and had no expected effect. And according to official statistics and reports, there had been no significant improvement in the ecological state of water bodies and in the quality of the Volga water. Here on these pictures, you can see, on these graphs, you can see an overall decline in the volumes of pollutants, such as heavy metals, nutrients, and oil byproducts. But at the same time, the concentrations of the same pollutants in the river Volga stay the same or sometimes even rise. So this is an obviously that this situation is due to due to diffuse pollution within the region. And Water Problem Institute, jointly with other leading research institutes like Institute of Limnology, Institute of Geography, Russian Academy of Science, Karelian Research Center, Institute of Ecology of the River Volga, conducting this challenging project in the framework of the National Federal Project Recovery of the Volga River. Our project is aimed to abatement, to development, general conception of abatement of diffuse pollution of the Volga River. And the research shows that the main sources of diffuse pollution of the Volga River is urbanization and site development, agriculture, transport activity, industrial territories and mines, and other sources. Here are some priority pollutants: suspended solids, nutrients, organic matter, oil byproducts, heavy metals, pathogens, and pesticides. Here are some results of our research that obviously show that in different parts of the Volga River, on different pilot watersheds that have been chosen to cover all the geographical conditions within the River Volga. In most part of these watersheds, the diffuse pollution was more than 40 or 50% for the Kama River, for chlorines, sulfates, and magnesium. The Bela River catchment oil byproducts exceeds 55%, organic matter, chemical oxygen demand, more than 35%, phenols and ammonium nitrate. Here are the Upper Volga River and the catchment of Moscow River. In this place, and the Ivankovo water reservoir, nitrogen and phosphorus input from diffuse pollution exceeds 40 and 50%, oil byproducts and organic matter 90%. Here are some examples, the results of modeling, hydrological modeling and hydrochemical modeling based on the ECOMAC, Informational Modeling System for Simulation River Basins. And this study allows to simulate concentration of heavy metals, here like copper, concentration and annual copper specific volumes that comes from the watershed of the Bela River. As the studies show, that the main reasons for diffuse pollution in Russia are weak water protecting legislation, low ecological awareness among land users and landowners and authorities, lack of attention to monitoring issues, water quality, along with human activities, insufficient incentive for land users to introduce best management practices on the local level, and lack of methodological approaches to evaluation and regulation of diffuse pollution. Now the general conception has been developed and is going to be presented to Ministry of Ecology of Russia, and we hope that this will be another large step to enhance water security in the Volga River Basin and in Russia as a whole. Thank you for your attention.
Thank you. Thank you very much. Thank you very much for your nice presentation, very informative. So our next speaker is Dr. K. Kumaraswamy. Yeah, so he is emeritus professor at Bharatiya University, Tiruchirappalli. So he's coming from the extreme south of India. So we have tried to cover the whole geographical area domain. So he'll be talking about an examination of water resources and human health in Tamil Nadu.
Yeah. Dear organizers, co-speakers, and the audience. Good evening, Honorable. I am Dr. Kumaraswamy from, as Saha has pointed out, extreme south of India. The title is on the examination of water resources and human health in Tamil Nadu. So this is the topic, and this is the state of in India, that is Tamil Nadu state. It extends from say 8 degrees to 13 degrees north and 76 to 81 degrees east. And this state is hard and fissured crystalline rock dominated state, the entire upper area. And we have a narrow alluvial tract stretching from North Chennai to Kanyakumari. We have the Western Ghats on the western side of the state, which runs north-south. The state is on the leeward side of the Western Ghats. The slope is from west to east. The average annual rainfall is around 950 millimeters. And we receive rainfall from both the seasons, southwest monsoon and British monsoon. These are the aspects related to the water resource development of in the state of Tamil Nadu. We receive the rainfall from both the monsoons, and therefore the rivers are seasonal in character because the evapotranspiration PET is 2,200 millimeter. Therefore, the evaporation and transpiration is very high. And we have systems tanks in operation, and canal irrigation is very much limited. In general, about 90% of the surface water is harnessed for various purposes. And the replenishable groundwater resource is 23.07 billion cubic meters because of the fissured zones. The grass irrigated area is about 3.1 million hectares, of which 38% is shared by groundwater, both open well and tube wells. The number of tube wells are in increasing order because of introduction of electricity in 1950s and 60s, and more because of the supply of free electricity to the farmers. In general, the groundwater development in the state is about 85%. The depth of the open well ranges from say 6 to 30 meters below the ground level, and in bore wells, it is stated by government agencies 30 to 100 meter, but in several parts of rain shadow tract on the western side, it is 300 meters. Out of the total of 385 assessed blocks, as Professor Sharma has pointed out, the state had more than 140 blocks overexploited, 33 critical, and 57 semi-critical in nature. The groundwater situation in the state is among the worst in the country, and it is a matter of concern. If you look at the groundwater development in the state, the red blocks indicate the red color, the red pattern in the state indicates the highly developed or overexploited blocks. It stretches from, say, northeast to southwest, and two of the blocks in the entire country are notorious in terms of lowering of groundwater. One is Chinnatadagam Basin in Coimbatore area, that is near here, and the other is Srivillikuttur area, that is very close to this particular place. So these are the two places which has been notorious. One, even in 1976, Ministry of Irrigation and Ministry of Agriculture report. Then looking at the groundwater quality, we have been receiving good surface water and safe groundwater a few decades before. But because of the rapid industrialization, intensive irrigation using free electricity and then borewells and wells, increasing standard of living, etc., which has led to severe environmental stress. Besides that, on the coastal area, we have the coastal saltwater intrusion along coastal rivers. A number of studies have been carried out in this part of the country. And all of them have altered the geochemical parameters. And if you look at the problematic blocks, if the salinity is more than 3,000 micromoles, then these are the districts. About 2/3 of the districts are under problem. And if you look at the fluoride, more than 1.5 nanogram per liter are considered as it's a problematic. And chloride also more than 1,000 milligram per liter, which has been reported in about 50% of the districts. And iron more than 1 milligram is reported in a few districts, and the taluks are more. And likewise, nitrate is also high, 45 to 50 milligram, is reported in almost all districts in the state. Okay. If you look at the sources of contamination, then you have specific areas like this one, number one, the Mettur, where you have industrial complex, mixed of thermal power plant to plastic companies, so they are concentrated and they are discharging. And another area is here, Vellore area, where you have higher number of tanneries. And here in between you have tanneries, and the third group is here. So on that you see that. And the hot spot is Salem and Central Tamil Nadu. Then second is total dissolved solids, which gives a clue on where you have higher number of solids in the groundwater. And more than 2,000 ppm is considered as unfit for drinking and even for irrigation. But we are using it. We have so many thousands of ppm in several of the samples. And we have a stretch starting from, say, this area, Vellore to Erode, to this stretch. And another stretch is Ramanathapuram Rameswaram area, where you have the saltwater intrusion, and therefore you have highest concentration, even more than 20,000 ppm hot water. If you look at the fluoride concentration, the hot spots with more than 1.5 nanogram per liter is observed in two pockets, one in northern side and the other near Tiruchirappalli Karur area. So these are the two pockets where you have more fluoride concentration, and we know very well that you have the problem due to in the tooth, then bone and the kidney. If you look at the nitrate concentration, then we have only few pockets which are known for higher nitrate concentration with above 50 milligram per liter, which are reported in 15 blocks. The reasons we know very well. It is because of a higher use of chemical fertilizer, then animal manuring, and then sequences. Then another interesting point is iron. More than 1 nanogram per liter, which has been reported in 3 blocks. One is the Kaveri estuary, second pocket is Dindigul, and the third is the Kanyakumari. So these are the 3 pockets. The sources of contamination, as usual, is in situ, rocks, and then the discharge of chemicals. The other contamination source is the chromium usage. We know very well that India is known for the tannery industries, which is the oldest and the fastest growing industries. It has been reported that 3 states share about 88% of the tannery units in the country, Tamil Nadu, West Bengal, and Uttar Pradesh, of which 55% is shared by Tamil Nadu alone, with 2-3 pockets. One is near Chennai, the second is at Dindigul, then Erode and Tiruchirappalli region. It is surprised to know that every year we are discharging about 2,000 to 3,000 tons of chromium, and they are polluting more than 50,000 hectares of land, both agricultural and other land uses. Then we have seen both the monsoons and mosquito-borne diseases are known for this area. We have 3 types of diseases: malaria, chikungunya, and then dengue. These are the major diseases which has been reported for so many years, maybe about 50-60 years. Even when Professor Learmonth of UK visited Tamil Nadu for a conference, then we went for a malaria hit pocket in a place, and then we conducted surveys and so on. So the water logging is increasing every year, and the mosquito eggs are surviving even with the strongest repellents. And recent years has seen the change in the behavior of the mosquitoes, because they can stand even for higher temperature and also even for lower salinity. Then we have conducted, there are 2 case studies on in the state. One is by Govindaraju and all in 2003, which they have selected about 20 villages with 1,120 villages, and they have conducted the survey with 11 doctors. They found that because of the effluent discharge in the Tirupur industrial area, we have skin allergy, respiratory infection, and then general allergy, gastritis, and then ulcer. These are the problems which have been listed by the study, in the study. Then second study by Rajan et al. In 2012, which reveals that there is an infertility problem in this area. It means because of the usage of the industrial water in the surface water and then the groundwater, infertility is increasing, and a number of fertility clinics have been opened in this region. So it means there is an urgent need to adopt the integrated water resources management strategies for sustainable use of water resources to maintain human health of the region. In particular, because it is only for this region, that is Tamil Nadu, but it is common for the entire country. Thank you very much for giving the opportunity to share my few slides with you on this. Thank you very much.
Thank you, Professor.
Thank you, Mr. Kumaraswamy. Very interesting and useful presentation. And I would like to pass the word to Vsevolod Moreido. He is the scientific researcher of the Water Problems Institute of the Russian Academy of Science. Yes, please, Vsevolod.
Yes, good afternoon, dear colleagues. I'm very grateful to Russian Geographical Society and to National Association of Geographers of India for organizing this wonderful meeting. My talk will be concerning the possible changes of water availability in the particular region of Selenga River, which is the largest tributary of world's largest and deepest lake, Lake Baikal, which is situated in Russia. But first of all, I would like to acknowledge my colleagues that took part in this assessment, this research, with Doctors Andrei Kalugin and Tatiana Milyonchiko of my institute, the Water Problems Institute of Russian Academy of Sciences, and Dr. Sergei Chalov from the Moscow State University, who is present here, and he had his talk already, who initiated the whole study. So the outline of my talk is, first of all, why do we need the regional assessment of water resources under changing conditions? What means can we use for this regional assessment, particularly the hydrological model ECOMAG, which was also mentioned by my colleague Vladislav Polyanin presentation. Case study of Selenga River and historical reproduction of climate and water resources by global climate models, projections for the 21st century, and assessment of alteration of river flow of the Selenga River. So why do we need the regional assessment of water resources in a particular catchment? Well, first of all, because in the arid regions, the water resources are extremely vulnerable to change in temperature and precipitation. Here you can see that the increase in annual temperature and decrease and stagnation of atmospheric precipitation has led to a severe decrease in this particular region, which I will be talking about in detail a little bit later. And second motivation is that the global atmospheric circulation models, I will be referring to GCMs later on, cannot resolve the catchment scales hydrological processes such as soil water content or river residence type or such or topography of this catchment, because their usual grid resolution is degree at or 0.75 degree at finest. So their modeling grid is quite sparse. So, but we can use GCMs for as a great tool for climate variables for projection in future, because they can involve house gases concentration pathways, which is very useful to as a forcing hydrological models. So regional hydrological models, the one that was mentioned in Vladislav's talk, is called ECOMAG, the one that we use for regional assessment. And it's a semi-distributed model that can account for different hydrological processes of runoff generation, such as precipitation, forming of snow cover, and surface water storage, and overland flow, evaporation from the surface from different horizons in the soil and groundwater, and finally routing of the water in river system. So with this model actually divides the catchment into grid cells, and this process, all the mentioned processes are calculated on a grid cell basis to integrate the runoff in the catchment to the outlet. So by use of various information such as the digital elevation model, soil map, and vegetation type map, and different databases of time series of weather variables, namely temperature, precipitation, and deficit, the simulation is conducted to analyze the runoff, soil moisture, and evaporation, but the initial data is transferred through the whole calculation scheme to the outlet point to analyze the river flow, the stream flow in the outlet point. The model was very intensively tested over very different conditions in Russia and several sites in around the world, you can see here. But for this particular study, we were interested in the reaction of the Selenga River Basin to alterations of temperature and precipitation in the near future, in the next 100 years for the first century. So Selenga River is the major tributary of Baikal Lake. It for around 50% of the inflow into the lake, which is a World Heritage Site. And 2/3 of the basin is situated in Mongolia, 1/3 in Russia. And it's the main river course is around 1,000 kilometers. So, as mentioned earlier, the river flow in the Selenga River Basin has experienced a significant decrease over the last 2 decades, which was mostly due to increase in temperature and decrease in precipitation. So hence the need to assess the future conditions in which the Selenga River Basin will be operating the harvesting water from its catchment. So as well as for its importance, I should outline that the Selenga River Basin data scarce region. So you see here the meteorological, the weather stations are shown, and the Mongolian part over which the majority of water resources is formed is scarce in amount of weather stations. So for this assessment, we used the reanalysis data to provide it to the hydrological model on a time step, as well as other information such as land cover, the soil cover, and digital elevation model, which were used to determine the specific characteristics of elementary watershed used as the elementary calculation unit. So to calibrate the model parameters and to assess the model performance, we used several gauging stations alongside the main course, so 3 namely here. And by calibration, we obtained the good performance of the model, namely the national coefficient of the model efficiency is above 0.7, which can be considered very good at 3 gauging stations. And we also assessed the mean monthly runoff termination coefficient and we were quite happy with that. So the verification of the model also showed that it's suitable for long-term simulation of water flow. So to assess the future conditions of the stream flow in the Selenga River Basin, we used 7 global climate models, which were used as a forcing to the model, to the hydrological model, and they had to be first bias corrected to match the reanalysis data in the catchment. So for the historical period, we assessed performance of these 7 climate models by comparing it with the reanalysis data, and for the amount of animal river flow, the models, each of the model and the average and ensemble, average of ensembles shown that there is a significant difference in the model and the observed trend. So we can state that climate models are not suitable to forecast the future conditions of stream flow, but they can provide interannual runoff change assessment, which will be used as a projection for the water resources in the region. So for this assessment, we took 4 International Panel for Climate Change relative concentration pathways that show different expectations of greenhouse gas concentrations in the atmosphere in the future now years. So from the mildest one, RCP 0.26, to the most severe one, RCP 8.5. So, and they show for this particular, for Selenga River Basin, that the temperature might not increase drastically in the one of the scenarios, and the other one is that the annual temperature can increase from sub-zero values. Annual air temperature can decrease from sub-zero values to above zero values. The precipitation change will not be as drastic as the temperature change, and evaporation of the temperature also can be quite drastic change in evaporation amount. So based on this assessment from different concentration scenarios, different models shown that the stream flow dynamics can be multivariate for different assessment periods. But in general, while averaging all the 7 models for these 4 particular periods, we can state that the Selenga River Basin will suffer decrease in water resources by the end of this century, with the most significant decrease expected over the most severe concentration pathway, up to -40% of the initial conditions as we have it now. So some take-home messages is that arid river systems are very vulnerable to change in temperature and precipitation, and the water resources planning should be conducted by constructing some regional assessment of water resources projections, which can be done with a useful tool to assess different parts of hydrological cycle, which are hydrological models, and the climate forcings are introduced directly in the hydrological model can provide this information for water resources planning. So thank you for your attention. I expect some questions from you.
Thank you, Vsevolod. Thank you very much. And now can I pass the word to Mr. Sunil Kumar De? Please.
Yeah, Professor Sunil Kumar De, he is coming from northeast in part of India. So he's the head of the Department Geography, Northeast Hill University, Sikkim, and he is currently the Vice President of International Association of Geomorphologists. So he will be talking on impact of human activity on river health and vice versa, a case study of Howrah River, Tripura. Professor De. Professor, could you please switch on the microphone? It's muted.
Okay, now it is audible.
Yeah.
Okay. Yes, at the outset, I am thankful to the organizers of the National Association of Geographers, especially Professor S.C. Rai, Professor H.S. Sharma, Dr. Ashish Saha, to give me this opportunity to speak in this Nobel webinar between NAGI and Russian Geographical Society. My topic of deliberation is impact of human activities on river health, and vice versa. It means that impact of human activities on the river and river, how it is taking revenge to the human health. So both way, I will give 2 examples from this river. But before that, I should acknowledge my co-researchers, Dr. Shreya Bandopadhyay and Dr. Sushmita Saha, for assisting me in the field as well as in the research activities. Now, before starting this issue, this river health is a new agenda in geography. For the first time, you know, this term was used by Norris and Thomas in 1999. And they had published a paper, What is River Health? So we were encouraged from their work. And after that, we have searched throughout these different sites, and we did not find any book or any other work on this issue. So we were encouraged to take this issue of research. Now, traditionally, the term river health is dependent solely on the measurement of physical, chemical, and some biological characteristics of the rivers. It is usually applied to the assessment of river condition and often found as analogous to human health. So there is no harm if we correlate any physical phenomena with human, because the term geomorphology, this morphology, the term came from the biology. It is not clear what aspects of river health, sets of ecosystem level indicators, actually identify, or how physical, chemical, and biological characteristics may be integrated into measures rather than just observations of cause and effects. So they are suggesting that each and every parameter should be measured properly, and then we'll have to find out what are the causes, and after that we'll have to propose what remedial measures we can take on the basis of our field research. It is exclusively a new branch both in geology and geomorphology and hydrology, as well as in environmental science. Now, physical characteristics of the river include the fluvial geomorphology and surface hydrology, everything of a river basin, which control the structure and dynamics of river channel. It may be river shifting, it may be river migration, it may be river sedimentation, any issue related to the physical characteristics of the river. Changes in flow and sediment regimes following catchment modification can markedly alter the physical nature of the channel. So it is also related to the physical characteristics. Moreover, the chemical indicators are the most commonly used for detecting the river health. It means that the quality of river water is related to this one, as well as the biological parameters in the similar. Certainly, it is argued that if the riverside habitat is in poor condition, the health of the stream would be affected adversely. It shows that if we have an unhealthy catchment or valley, we would have an unhealthy stream. Like many researchers from Russia before, they have presented that what are the sources of non-point pollution and related aspects of this sources of unhealthiness of the river. Similarly, this assessment can also do in a reverse. A stream may be assessed as being unhealthy, and then it is concluded the catchment is unhealthy. So, in a nutshell, we have tried to define these river health parameters in a different way in terms of biology. Firstly, it is the anatomy of a river. Number two, it is physiology of a river. Anatomy of any river mainly includes the physical condition of the river, including the changing hydrological behavior of the river, channel shifting and migration, river course change, flood and riverbank erosion, and related phenomena. Whereas the physiology of any river includes the chemical and biological condition of the river water. So this is the water quality. Thus, river health is a subject which combines fluvial geomorphology, river hydrology, and environmental pollution. It is worth mentioning that all of the aforesaid conditions of the river health may be changed due to human intervention, because nature understands more than man. Every time we suggest, and we are intervening nature and changing their life, and now we are trying to find out the policies of restoration of those aspects. Now, this is this newspaper report about degradation of this Howrah River due to human intervention, and see in the sideways different types of human interventions are taking place. And we have divided, this is the river course. This is in the northeastern part of India. It's a landlocked state. Here it is Bangladesh. And of course, the northeastern part, state is covered, and this river is an international one. Here you see it is Bangladesh, and here it is Agartala. This is the international boundary. Originating from this state, the river is meeting with the river Titash in Bangladesh. Anyway, this was a tributary which is known as Katakhal. It means this human-made canal. It was a tributary afterwards. Now we have divided this river course into 4 segments according to the nature of human intervention. And you know, the lowest one, this course change of the Howrah River, I'll show this publication, here it is. This was the tributary. It was meeting with this river, this Howrah, and afterwards this main river is flowing in its own way, and now you cannot find the tributary, it is meeting differentially. And this was the course, Howrah River course. Now it has become this Howrah River, and this is Katakhal River. So it was a tributary earlier. Now we went to this area in Bangladesh and tried to find whether there is any case of sedimentation or not. But ultimately, we have found that the rate of sedimentation is so less in this area that it cannot be done. Then we proposed this model due to neotectonic activities. The mouth of the river has been risen, and these 2 rivers have been detached from one another. Okay, next one, this is one area which is called College Tila. Tila is an upland in Indian, literature it is called Tila land. It means that one upland area. It's not very highland. So this College Tila, it means that there is a very old college is situated. This canal, this was the previous course of the river. And this canal was dug by the kings, the then kings. And now the river is flowing through another channel. And between these two, the natural channel as well as this artificial cut one, because of this river shifting from this College Tila area. Number 3 course, this is human interventions. You can see along this river bank how much amount of material are dumping by the local people. And we have taken this cross section from the field with the total station. And since 2001 to 2012, this 3 years consecutively we have taken. Within 3 years, this much amount of change has been taken place. This was the previous bank, and now this is the present one. So if this amount of materials are deposited by the local people, then naturally the river will react reversely. And this is 4th one. And these red spots are the brick industries, brick kilns. And they collect the sediments from either from the river bank or from the tiller land. Because most of the upland areas have been generated during this post-Pleistocene, means this during this Holocene period. So most of the sediments are Holocene sediments. It is very soft in nature. They are silty and clayey in nature. So they are cutting these upland areas very easily and using this thing in the brick kilns to produce bricks. Now, see, they are dumping all these materials along the river bank. So these are the end products. These are the end products of this river bank from the brick kilns. And it is coming down the river. See, this is the lifeline. It is whole Agartala city is dependent on this river. And see the nature of the river, it is gradually shrinking. So, and due to this way, these point bars are forming in the river side of this one, and gradually the river is cutting on the other side, and there is a national highway, and the national highway is in problem now. Now, see, these are the activities, and these materials are coming down. They have barricaded this river because maybe due to this protection, but these materials are coming down and being deposited here, forming these river bars and shoals, and ultimately river is gradually dying. Now, these materials, these are the end products of these brick kilns. They are coming down the river, and it is sticky soil. If you keep your foot here, if you keep your feet here, you will slip down. So naturally, they are this sticky in nature. Rate of erosion is very less on these materials than the alluvium soil. So naturally, I will show this one. These are the materials we have collected, and this is alluvium, but these are sticky soils, and it is rich with iron content and other this brick ash contents. So This is hampering the natural flow of the river. And see, this tilla land means upland areas. These are the brick lanes. These red ones are the brick lanes, and they are cutting these tilla lands. I will show some of these photographs. See, this was the amount of cutting, 6.1 meter. Just if you continue this one, the tilla land was extended up to this. So they are cutting this tilla land and producing these brick lanes. Not only this, the whole upland area have been converted into flat land. It is not plain but flat land. And this is gradually the tilla land, these upland areas are gradually reducing. Just see, this was the previous one, and the green one is the recent one. Now see, this much amount of land has been reduced. So we are converting the topography as well as we are responsible for this impacting the river directly or indirectly. Now see, these upland areas have been destroyed. This is river bank area, this floodplain area. They have collected these sediments for these brick lanes. Now they will use this thing for agricultural purpose, but they need huge amount of fertilizer or manure for cultivating this one. Usually these river floodplains are very rich in these nutrients, but here since the topsoil cover they have taken out, now it is gradually degrading. And these are the scenario. And see, other human activities. This trucks, this is river valley. This is the river valley. Across this river valley, this causeway, they are collecting the sediments from one side and crossing this river in for supplying these materials to the other side. So these numbers of causeways have been created by this, and these are unmetal causeways. And see, these trucks are crossing this way, and by this way the river is also gradually dying. It is under dying condition. So sand collection, unscientific way, they are dumping along this one. They will take after that, and this irregular surface river bed will be created, will be generated. So this way they are hampering this river bed. So these are the human activities, and these bars and shoals are formed. This is the bridge pier. And you know, river fluvial dynamics says that when this river is obstructed in the front side, the velocity of the gyre will be zero after a few years or few meters, and the sediments will be deposited in the front side. So by this way, the river is gradually dying. And these are the activities, these are the numbers, and downstream side, these are the impacts of this river bed. And these are some of the constructed causeways also. This is a bridge which was constructed for the time being for carrying huge load of vehicle for this gas turbines. And after that they have cut, but the sediment, while they have gone down the river. So anyway, we have created this way on the basis of the human impact. We have divided the whole river valley on the basis of this intensity of this use. Now, second one, very quickly I will finish because 15 minutes time I am given. Now, settlement, these are the slum areas along the river. You know, this Tripura is very close to Bangladesh border. After 1971, many people crossed the border, and these poor people, poor class people, they have settled along this river bank, and you know, they do not have any capacity to construct any proper house, proper sanitation system, anything. That's why they are hampering this river this way. So we have calculated this human impact on this with this formula. I'm not going into the details. If any question comes, I will then one. This numbers of latrines. One is metal, semi-metal, then unmetal, then there is no latrine. And by this way, we have divided the whole study area into different sectors, different blocks, and we have counted. After that, we have superimposed. And from this one, if we see this, these are the very limited places where you will find proper latrine systems. So where they are committing, I will show afterwards. So these are some of this one. This is this metal. So here near this Agartala, only very few areas. This is semi-metal latrines, and this is the way. This is the way. And somebody is saying that this is UNESCO. UNICEF prescribed. I doubt whether it is. Anyway, say there is unmetal it means that the excreta is directly coming down the river. If you consider 60,000 population are there and they are committing nuisance regularly, so this sediment is directly coming down the river. It is not only increasing the sediment load, but also increasing the quality of water. And this is this one. Now solid waste disposal. So this is the concrete map. These areas, these solid waste materials along this river in the urban areas where the population concentration of marketplaces are there is the highest. So we are consciously or unconsciously doing this one. Now drains, just see major drains. See, these are different types of drains which is coming down the river with all these urban materials, waste materials. Then garbage disposal sites. So I have already shown. Again, this is also supplying huge amount of contaminants to the river water, and the river width is also. Ultimately, we have tested this. We have tested at least 10 samples, but here I am showing 5 samples. And with these 5 stations, we have taken 2004. This is not our data. This is Pollution Control Board data. From 2010 to 2013, we have tested this thing. And it's found that everything is in varying condition. So it is said that BOD, if the BOD value, somebody asks me if the BOD value is more, then it is good for the river. No. We have some misconcept. If it is 1 mg per liter, then it is healthy. You can drink the water. If it is 3 mg per liter, up to this it is tolerable. But if it is more than that, then it affects the sediment coagulation in the river system. Although it is good quality water maybe, but it impacts the sediment coagulation system in the river water. So naturally, all these materials are in varying condition within these 3 years. Just imagine, say chloride level is increasing, then alkalinity is increasing, then this temperature is also increasing more. So if all this quality of the water is in varying condition, then we should think about the necessary measure for checking this river. Number 1, physically it is dying. Number 2, the water quality is also gradually decreasing. So naturally, on the basis of this one, what is the impact of this water quality? Say acuteness of infected diseases. Many people are illiterate along this one, and they cannot reply the answer properly. Then we have a doctor, university doctor. We took him for 5-6 days in the field. Then we have tested their samples and found that most of the diseases, stomach diseases, mostly are due to this bad quality water system. But they do not have any awareness. They are taking this water directly without boiling or without anything. So now we have proposed some measures for this one. Unscientific collection of sediment from the riverbed should be stopped. And this project was done under the mission of the then Chief Minister of Tripura state. I do not know what is the state now. We are given this work to save these major rivers of Tripura. We have completed 4 rivers. And we have proposed accordingly, mapped this area. Then unscientific collection of soil from agricultural land along the river bank. This should be limited. Waste material of the brick field. Now, if you say this thing, the brick owners will say then development will be stopped. Then I doubt. I asked them, what is the scale of development? Can you define? You can see the demand in the city, and you are supplying, destroying the natural environment. So after a few years, if you see that if this geomorphological geological balance is lost, and if any this type of geomorphological hazard takes place, then who will be responsible? You or the stakeholders or the government? Anyway, construction of new brick fields should be banned. Dumping of solid waste and disposal of toxic substances into the river should be stopped. Along the river, there are many semi-literate people also, like school teachers, and we tell them semi-literate. We ask that why are you dumping these materials along the river bank? There is a bhat a few meters away. They replied that what is wrong with it. So if this be the awareness level, then it is of course a problem in the country. Now most of the slum dwellers along the river of Agartala city are directly dependent on the river for all the said purposes: bathing, animal bathing, car washing, then cleaning all these utensils, dress materials, everything, all types of works. But all the malpractice such as huge rate of excreta disposing, industrial and domestic garbage disposing within the river are making the river sick. The quality of the water is becoming worse day by day. As a result of that, people who are living along the Howrah River are also getting affected by that. Even after enactment of Water Prevention and Control of Pollution Act, as early as in 1974, there is an international act. It may become a source of geopolitical conflict between India and Bangladesh, upstream and downstream water user countries. Upstream is Tripura and downstream is Bangladesh, because the latter suffer from the effects of upstream pollution. With these words, I thank you very much. And these are some of our publications related to this one. This is a channel platform change in the lower part of this one. This is from Elsevier Geomorphology, and this is from Paris, Anthropogenic Impacts of Morphology of River. And after that, if anybody is interested to see this book, it is available in your country, Library Genesis Russia. So you can download it free of cost. So we have introduced this term in river health, and we're trying to popularize the subject throughout this world. With this word, I thank you again very much for your patient sharing. Thank you.
Thank you, Professor.
Thank you, Professor. The very interesting presentation. And I would like to pass the word for final remarks to Professors Naumenko and to Professor Rai, please.
Well, I want to say a few words for conclusion. There were very interesting and useful presentation about water problem of Russia and India. I believe our contact should be continuous. For beginning, we can exchange our publication, and maybe can use site ResearchGate for exchange of our publication. I can thank to Elena for her work to join us. Thank you very much for future meeting about hydrology.
Thank you. And Professor Rai, please.
Yeah, thank you very much. This is, I think, is a good initiative by both the associations, and the presentation, selecting of the paper for presentation in different aspects: groundwater, wetland ecosystem, surface water, river basin. So I think, in my opinion, this is a very good initiative and it's a good presentations. And I think, I hope that those who are watching this conference on YouTube, they will be very beneficial from this. And I hope in future we will also collaborate this type of conferences, so the academic exchange between two association will enrich. Thank you very much, Elena. Hello.
Thank you,
Yeah.
everybody. And probably Mr. Saha can speak some words also.
Yeah.
Turn off your microphone, please. Turn on.
Okay, thank you very much for joining this conference, and it is really helpful for everybody, and we'll hope that we'll have more collaborations and such kind of presentations once again in near future. So the time has given us a big opportunity, and we have taken maximum benefit out of it, and hope we'll be doing it in future also. Thank you, Elena, for this organizations and all other colleagues from the Russia and India for joining this program. Thank you.
Yes, and regarding the questions, because we have the translation on the YouTube, as you know, and a lot of positive questions and feedbacks. So Mr. Sahar has provided the email, and he will collect all questions, and after will spread through us or through myself, and I will email. We will decide how we can do this. So stay in touch, and I hope we will meet again.
Yeah. Yeah.
Yeah.
Yeah. Good evening.
Thank you very much.
Good evening. Yeah.
Thank you.
Thank you. Namaskar.
Thank you.
Goodbye.
Very much to everybody.
Thank you.